Hi there, guys. Well, welcome back, and congratulations if you got through the epic of exercise 2R and the epic video that was there. In that video, obviously, we looked at combinations of transformations in the x direction. So how do you represent two transformations, one of them a stretch and one of them a translation in the x direction? That was where we started with. Okay, well, this one's going to be much quicker because we've got example 40 here and example 41, and then we are done. You're on to 4S. And this just seems to be really talking about more just different types of functions and then multiple transformations applied to them. So it's just bringing together a lot of what we've done already. So there's no real new ideas here, really. You'll be relieved to know. Okay, so for example 40, it says explain each transformation necessary in order to obtain the graph of y equals -2. You can see this thing here, -2 modulus brackets 2x plus 1, close them off, and -2. From this original graph, the original modulus graph, modulus of x, that basic modulus graph or absolute value of x, that one, okay? So, and draw the graph at each stage. Now that's the problem. And again, I'm not going to spend my time doing all of this, but I'll sort of kick it off and then I'll do the rest on Desmos, because again, it just gets too fiddly for me to do. Okay, now if we set up our original function as the modulus of x, that's f of x there equal to the modulus of x, then what we want to do is shift to this function here, where we're replacing x in the modulus of x by 2x plus 1. Okay, you don't need modulus brackets here because that's actually defined in the function. And then we've got the -2 there, and we've got the -2 there as well. Now, that's going to be the same as -2 lots of f of 2x plus 0.5 minus 2. And the reason why we put it like that is because it's going to be easier to do the horizontal stretch, especially when this thing is symmetrical, this graph. So it's going to be easier to do the horizontal stretch before we do the translation. If we do the translation first, then a stretch of something like this, let's just move something back by 1. If we have this graph here, so the modulus graph shifted back by 1, and then if we try and make a stretch in that case, that's really quite difficult. I know this point is going to stay where it is, this point is going to go twice as far away, but it's just easier to deal with if we have a symmetrical graph. It's much easier to deal with the stretch first, which is the case here. So we're going to put it in that form to start off with. So, okay, so explain each transformation necessary. Well, here we go. The transformation necessary is going to be let's deal with x first. We'll deal with stretch in the x direction by a scale factor of a half, followed by, second thing, let's do all of the inside first, and then let's do the translation. Translate by -0.5 in the x direction. And then the next one is going to be a stretch, and let's split this in two like they did before. So stretch in the y direction by a scale factor of 2. Okay, we're sort of ignoring the minus there. And then we're going to say reflect in the x-axis. Okay, so you could really say, as I said before in the previous video, you can say this is a stretch in the y direction of a scale factor of -2. But I guess it's pretty nice how they split it up and said, let's do a stretch of a scale factor of 2, and then let's reflect in the x-axis, because you see there, we can add in another transformation. And then finally, we're going to translate by -2, by -2 in the y direction, so down by 2. So we're going to put -2 there. Now we can switch around these if we want to. So if we want, we can call this. So obviously we've got it in this order. We've got 1, 2, 3, 4, 5, but we can switch this all around, and we can do all the y stuff first. We can do all this, and then we can do all of this. And again, we can do, we could say, for example, I'll do the stretch in the y direction, and then the translate in the x direction, and then the stretch in the x direction, and then the reflect in the x-axis, and then the translate in the y direction. As long as the translate comes after these two things, and as long as this translate comes after this, it doesn't really matter which order we do these things in. But I guess it's nice to do all of the x's first, and then all the y's first, and then all the y's, or vice versa. Okay, so we can have a look at how they've done this one here as well. And so you can see, tell you what, let's actually do this on Desmos. So actually, just put a new Desmos in, quicker for me to do that. And we can see, what have we got? We've got y is equal to the absolute value of x. Okay, so that's our modulus brackets basically. I wonder if we have modulus brackets in here. I think it might just be written as absolute here. Okay. Don't know where it is. Okay, but anyway, we're writing it as absolute here. Okay. So we've got y is equal to the absolute value of x. That's where we start. And then we said, let's stretch this by a factor of, sorry, I'm forgetting this now. Stretch by a factor of a half. Stretch by a factor of a half is going to take it to this function. So the next function is going to be y equals absolute value of 2x. And the next one was, well, f of x, if you want to call it y. F of x is equal to 2, and then we had x plus 0.5, I think. Okay, so we essentially factorized this thing in the center. So that's what we did. And we'd factorize this thing here as well in the same way. And then we've got the 2 on the outside of this. So let's just copy this. Okay, so copy this one here. And we've got the 2 on the outside. And then again, copy and put on the next one. We've got, I'll explain it a bit in a moment with the point, with a particular point. And then we've got the minus 2 in front. And then finally, we've got the plus 2 on the end. Is that right? No, minus 2 on the end. Minus 2 on the end. Okay, minus 2 on the end there. Okay, so we can take a coordinate point through each of those. But what's essentially happening is we've stretched by a half to take us from the original red line to the blue line. So we've stretched in the x direction by a factor of a half. So let's take that, and let's say a coordinate point there could be, let's take the coordinate point 1, 1. Let's take a really easy coordinate point. Okay, so that's now going to become coordinate point of 0.5, 1. So that's the next point. The next point is then saying, let's shift this thing, let's translate it backwards by 0.5. So we're going to get 0, 1 on the next graph. So that's now the purple graph. Okay, and the next thing to do is we've done the x transformation, so we've got the y transformation. So we're going to then times the y value by 2. Okay, so we're now stretching the purple graph to get the green graph there. And then the next thing to do is a reflection on the x-axis. So we're going to get 0, minus 2. So putting a minus in front gives all of our heights, changes the sign in front of all of our heights. And then final thing to do is then move that down. So we're now down from green to the black graph, and now we're going to the final red graph at the bottom there, which is going to be at 0, minus 4. So it's taking us to that point. So that's the progression of a particular point through those graphs. Now, obviously, that's really complicated to draw in each case, and you really need to take a couple of pages there to keep drawing out each next change. Okay, right. So You can see obviously they've done that as well. Hopefully, if you've listened to the previous video and if you listen to my explanation there, they talk about h of x now they're taking the previous function g of x and replacing x by x plus a half. So they've done it step by step. They haven't said f of x is equal to they haven't said h of x is equal to f of 2 in brackets x plus a half. They've done steps from each next function to the next function. So they've made one transformation at a time. Yeah, okay. I wonder what they do after they've come from h of x. Well, they go to p of x and so on, and q of x. Ooh, I wonder if I can write p of x on Desmos. Just check this one out. P of x equals, yeah, it doesn't mind that one at all. Actually, maybe I could write other things. Can I write j of x? I was thinking that I couldn't before. Oh yeah, I can. I'm done. Okay, so that's that question. Let's look at, I mean, you can look through that as well in your own time. I'm not going to draw out myself, it's going to be a bit messy. And example 41 says, explain each transformation necessary in the correct order to obtain the graph of y equals minus the square root of 2 minus x, and then plus 3 on the end. So from the original graph of y equals x, square root of x. Okay, so let's take this one. Example 41. So if this is our original function, we're saying that f of x is our original function, that's our square root of x. Then we need to transform to this correct order in order to obtain the graph from this graph. Yeah, so it is from this to this. It's the other way around. You'll need to undo all of these transformations, which we're doing now. Okay, but so it's this way around. So we need to get to a point where we've got f of x is equal to, and the transformations are, inside the brackets, or outside the brackets, we can clearly see we've got a minus, and we can clearly see that we have a plus 3 there. But inside the brackets, we're replacing x by 2 minus x. Well, that's not in the form that we like. Okay, so we like the form of a of x minus b on the inside. So we want really to take out a factor of minus 1, I think. Take out a factor of minus 1 there, and we'll get x minus 2. So we want the x to come first. So we can do that by taking out a factor of minus 1. So we can create this as our transformation. Okay, so that gives us this function here. If we apply, we substitute in this for x times by minus 1 and add 3. Okay, but in terms of transformations, let's deal with the x direction first. Remember, it goes the opposite way around to what you expect. So the thing on the outside of the brackets is what we're dealing with first. So in the x direction, well, replacing, if you go f of x minus x, remember that's a reflection in the y-axis. We dealt with that earlier in the chapter. That's also a stretch in the x direction of a factor of minus 1, but it's easier to say a reflection in the y-axis. So first thing is we're going to do a reflection in y-axis. That's the first step. Then we're going to do the translate by plus 2 in the x direction. You should figure that one out now that we're doing this the other way around, what we expect. And then we've got the things happening on the outside. So we've got the times by minus 1. So now it's a reflection in the x-axis. So all of our heights are going to become negative, or negative heights are going to become positive. And then we're going to translate by 0, 3. Now, again, you could deal with this by saying reflection in y-axis, reflection in x-axis, and then just translate by the combined vector of 2, 3. That would also work. So that would kind of cut down the amount of steps which you would need. Okay, let's see how they've done it. So they've said translate. Ooh, translate in the negative x direction. Okay, right. So they've dealt with, okay, they haven't done it like I've done it. Okay, so they've said, let's do f of x plus 2 first. So they've moved it first, and then, let's just see what I did. Yeah, so they've moved it by 2 first, and then they've reflected it. But the consequence will be the same. So let's have a look at this. So let's go up, let's come up with another Desmos. Desmos here. And we've got y is equal to the square root of x, square root of x here. That's our original function. Now I've taken it and I've said, well, first thing to do is we can do square root of minus x. That's the first transformation. And then I said, well, okay, we've got square root of minus x. And then I've put inside the brackets, sorry, I put minus 1 there. And I put inside the brackets x plus 2. Done it? No, I haven't. I've done x minus 2. I didn't think I was getting the right thing. X minus 2. Okay, so it's shifting it forwards there by 2. So in this case, it actually they've taken it a different way around. So I would always recommend putting it in those brackets to get the x foot first. So this form is better than dealing with this. But you can see what they've done in the book is they've actually said, okay, well, we'll do the shift first, and then we'll do this. Yeah, I mean, I think it's easier to see through this way. So I would stick with my method here. Okay, so yeah, if you always put it in that form to repeat, put it in this form here, and then you're not going to get it wrong. So you're always going to do your stretch first and then your translation. Okay, so once we've done this and this, which is what I've done, then you can say reflect in your x direction. So reflect in your x direction is going to be this thing. Let's copy that with a minus in front of it. So there we go, we've got a minus in front of it. And then finally, we had on the end here a plus 3. So we'll put plus 3 on the end there as well. Now, that's where your final graph should end up. That's your series of transformations. I think that my order is pretty nice there. I'm going to stick with that. And let's take a coordinate point which would work. Let's take, for example, the coordinate point, I don't know, 4, 2. Okay, so if we take the 4, 2 on the original graph, that's first of all going to become the coordinate point minus 4, 2 with the reflection. Then you're going to have the shift forwards, the translation forward, so it's going to become minus 2, comma 2. Yeah, that's shifting it forwards by 2 or translating it in the x direction by 2. So it's adding 2 onto this number here, onto minus 4 to become minus 2. And then in the next step, to get to the purple graph, we then need to make or reflect in the x-axis. So we're going to do minus 2, comma minus 2 there. All of our heights are going to become negative. And then finally, we're going to add 3 onto the y number. So we're going to say minus 2 and then comma 1. And that's the final transformation in this case. So that's just me following through a point to see that it's right and to see that I've drawn those graphs right as well. Okay, it probably asks for the domain and range of this function. Does it ask for that or not? Confirm graphically that your function, your final graph is correct. Okay, well, we've done that. But I would expect an extension question here to say, well, what is the domain and the range of the final function? let's just answer that as well. So I expect that to be a final question or an extension part. And you can see that for the black graph, we're only getting X numbers. We're only allowed to put in X numbers which are 2 or less. X is less than or equal to 2. And for the Y numbers for the black graph, we're talking about only getting our answers which are below 3. So Y is less than or equal to 3. So we can say X belongs to our real numbers and Y belongs to our real numbers under these two conditions. And that's how I would finish off my function at the end there. Okay, so once I've stated this function here, I would then say, here are my conditions to be complete with this function. Okay, well, again, if you want to have a look at the way in which they've done that and see the fact that they've swapped around the two X direction translations and stretch in the X direction, then by all means you can do that. And then you can see their order of things here. But obviously they get exactly the same answer at the end as well. Okay, so that's the last question in the book. This is exercise 2S. And after that, you've got a chapter summary, which is obviously going to be massive. Okay, it's enormous. And then you've got the chapter review. And obviously the chapter review questions are really good because it's mixing up all of the concepts that you've learned now and putting them all together. So these questions are very much like exam questions, even though the first ones aren't stated with the marks according to the exam questions, but they are very much like exam questions, like shorter exam questions that you could get. And then, of course, we've got these extended kind of exam questions here as well, in particular towards the end there. If you have a look at, for example, question 15, that seems quite extended. Well, there we go. Obviously, keep those ones for revision if you haven't finished off everything else. And then the next chapter is all about complex numbers. Okay, so well done, guys, for getting through the second unit. And I'll see you here again for the next unit.